All right, folks, let's go ahead and get started. It seems like yesterday, a few of you still had some issues with getting the assignment done, watching the video, and getting the work done. So I'm gonna go ahead and I'm gonna refine it a little bit, and I'm gonna take about 5 minutes off of the lecture here, so that way then it'll give you time to get the work done in the video, the work done that's required of the video, and then submit it as well. Okay, so let's see how it works. Like I told you, we're gonna have to try to figure this out as we go. We had a new schedule this week, and so we'll go ahead and work that out. I saw a couple of you yesterday after school. You had questions about the conversions. That was good. Please make sure, folks, since we don't have the interaction during lecture, that you come by after school at 3:15, and we'll go as long as we have to. Come on by Zoom classroom, check in, ask your questions. We'll work it out. I'll make sure that I work out these problems for you live, and then you can ask your questions so you can get instant feedback there. So please make sure you get that done. For me, I think this calculation is very doable for you, but like I said, you got to practice it and get your questions answered. Okay. So with that said, then let's go ahead and quickly review. I'm going to start out here with a quick review problem, because as we move forward, if we're going to use the molar mass, folks, if we're going to use the molar mass, you have to get the correct formula. If you don't get the correct formula, it's going to be very difficult for you to get the correct molar mass. If you don't have the correct molar mass, then you're going to have a very hard time doing these calculations. So what I'd like you to do is take a couple of minutes, try to do as many of these as you can, and then I will give you the answers for these here. So make sure you write down the answers on your paper, the paper that you'll turn into me at the end of the discussion, at the end of the lecture period. So go ahead, so take about a couple of minutes, do as many of these as you can, and then we'll start with this when you get back, okay? So go ahead and get number 3 done in your problem set. Get that done, write it on your paper, and then we'll go over it, okay? Go ahead and get that done. Okay, let's go ahead then. Let's take a look at what we have here. Okay, so let's make sure you are able to see then, identify the difference between ionic compounds and molecular compounds, and be able to use the rules that we learned back in chapter 7, 8, and 9 to get these done. Okay, so I'm going to go ahead and give you the names. If you have the formulas, I'm sorry. If you have any questions about how we come up with these formulas, again, stop by after school today at 3:15 to 4:15 to get your questions answered. Okay, so make sure you write down these answers here on your paper, okay? And that way then you can have something to work off of, okay? And also, so you can come by and get your questions answered. So please make sure you write these down, okay? Okay. Phosphide is Mg3P2, then barium nitride is going to be Ba3N2, okay? All right, so hopefully you folks are able to get this. Make sure then you come by and you see me if you have any questions on this, and then we'll go over. Okay, so if there's any part of this that you did not get, folks, you got to make sure you get that done. Okay. All right, so let's go ahead and let's pick up where we left off with yesterday. We were able to learn about the molar mass conversions, that is using molar mass to find the mass of the moles of a particular substance. If the substance happens to be an element, you can get that molar mass directly from the periodic table. Okay, the periodic table will give you the molar mass. You just find then the mass number of that particular element, and that's the molar mass of the element as well. And remember, the molar mass is defined as the mass that is equal to 1 mole of that substance. And because of that equality, we can go ahead then and use that molar mass as a conversion factor in order to convert between moles and mass, or mass and moles. Okay, so make sure you keep that in mind. Then we were able to, before that, we learned about the relationship between the unit mole and the number of particles. And that relationship is based on Avogadro's number, which is 6.02 times 10 to the 23rd. And so remember, for that particular way that we were looking at the mole, that we're looking at the mole there as the equivalent to a number of particles, just like the unit, just like the word dozen is equivalent to a certain number of objects, and that number is 12. Well, with the mole is equivalent to a very large number of objects, and that number is so large and it comes up so often, we give it a name and we call it Avogadro's number. And that Avogadro's number is 6.02 times 10 to the 23rd. And so we have two relationships that we can take advantage of to do our conversions. Okay? And so the third one then involves then what we call the molar volume. Now remember, with the molar volume, what we learned then was that the molar volume, what it's defined as, and I'm sorry, go ahead and do this. Molar volume is defined then as the volume that is occupied by 1 mole of a gas. And that volume is defined then as 22.4 liters of the gas. And the identity of the gas here, folks, doesn't even matter. But this many moles of a gas will always occupy this space as long as this condition is true. And STP then is defined then as 0 degrees Celsius. That's the temperature. That's standard temperature and pressure. So the standard temperature is 0 degrees Celsius, and the standard pressure is 1 atmosphere. So as long as you have these conditions here, we can use this relationship here, which is what we refer to as the molar volume, or the volume occupied by 1 mole of a gas. Okay. All right. So once we have that established, okay, so we left off this, so please make sure you write this down. Okay. Once we have that established, then we can go ahead and we can work out this problem. We can do this conversion here. And with all conversion problems, remember what you have to do first: ask yourself 3 questions. What do you start out with? What do they want you to solve for? And what's the conversion factor will get us from start to finish? Well, if you notice here, this is what we start out with. Okay. We're given this, so this is our starting amount. Okay, so that's what we are. We are asked to solve for the volume, so they're asking us about the volume. So that's what we're going to end up with. Okay, and so our conversion factor, since we have a gas at STP, we can go ahead and use this conversion factor right here, our molar volume, to get that done. Okay, so let's go ahead and let's set up our conversion problem. So we start out with 1.34 moles of sulfur dioxide. Okay. Now, you're not expected to know that sulfur dioxide is a gas, okay, but I do, and so I can let you know that. Okay. However, in your book and later on, I will actually specify for you that what we have here is a gas. Okay. So you can go ahead, if the gas is at STP, you can go ahead and use the molar volume to solve for the volume, and the volume will always be in liters of that particular gas. Okay. So with this particular problem here, since we start out with moles, if we're going to use the molar volume, moles should be on the bottom, moles of SO2, and then the volume then, which is 22.4 liters, should be on top. Why? Because then that allows us to cancel out that unit of moles. You plug that into your calculator, you multiply 1.34 by 22.4, and you get your answer then, 30.0 liters. That's your final answer. 3 significant figures here, because you start out with 3 significant figures here. Okay. All right. So I think that's a pretty straightforward problem. Your homework for tonight is going to ask you to do that. So please make sure you get that work done. Okay. All right. With that said, then moving along, what we need to do now then is there is a 4th type of conversion that we can do, and that's a conversion that allows us to find the density of a gas. And remember, density is an intensive property of any substance. It's an intensive property because it's unique for that particular substance, but it's an intensive property that measures that is defined by the ratio of mass to volume for that particular substance. So that's what we learned back in chapter 2. So you want to make sure you keep that in mind. So what we're going to do here then is, if we know, for example, the density of a gas, we can obtain that because we can measure out the mass, we can measure out the volume. If we can get the density of that particular gas, we can, under certain conditions, calculate for the molar mass of that gas. And so once we have the molar mass of the gas, then we can go ahead at that point and try to identify it. Okay. All right. So with that said, then let's go ahead and see how this conversion works. Okay. So I want to go ahead and start to show you how this works by just analyzing some units here really quickly for you. Okay. So let's go ahead then and let's consider this here. All right. So I'm telling you that if we start out with density, okay, so we start out with density. The units for density then you recognize can be grams per liter, so mass over volume. Okay, and so with that said, then I told you from here we can go ahead and we can find the molar mass of the substance. Okay, so the molar mass of the gas. Okay, and the molar mass then, remember, is in units of grams per mole. Okay, now understand, this conversion can only work, this conversion will only work if, first of all, that the substance is in the gaseous state, so it has to be a gas, and secondly, the gas, this particular gas here, has to be at STP, which again then is 0 degrees Celsius, and the pressure is 1 atmosphere. So if these are the conditions that we're working at here, we can go ahead and do this conversion right here. We can go ahead and do that conversion. Because consider this here. Remember, under these conditions here, we can use the molar volume. And the molar volume, remember, is 22.4 liters for every 1 mole of the gas. Okay? We can use this as a conversion factor. And so just taking the units here, you guys, just taking the units, and we'll have to make sure we plug it in correctly, but we're going to use the molar volume here in order to get that done. Okay, and so how will we plug in the molar volume here? We start out with density and we want to get to molar mass. Folks, we start out with grams per liters here. We want to end up with grams per mole. If you notice here, the gram stays intact. It stays in the numerator. What's different then is the liters on the bottom here and moles on the bottom here. So I want you to think about this really quick while I write this out for you. How can we plug in the molar volume here in order to get rid of the unit liter and introduce in the unit moles? Well, if we have the volume on the top and the moles on the bottom, so if we write it so that the liters is on top, moles is on the bottom, the unit liter there cancels out, and look at what we have here. We have grams on the top, and there it is. We've introduced in the unit mole, and it's in the denominator right there. Okay, so when we are solving for these problems here, when we're doing this last type of conversion here, if we're given the density of a gas, we can find the molar mass of the gas by multiplying by the molar volume. Okay, we're going to multiply by the molar volume in order to get that conversion done. Okay? All right, let's go ahead and let's take a look at our problem where we're going to be asked to do that. Okay, so let's read this problem here. And let's identify what we're given. Okay, so first of all, we are the density of some compound, some gaseous compound. So there it is. We have the term gas, so whatever this particular substance is, it's a compound made up of carbon and oxygen, and it's in the gaseous state. We have a gas right here. Okay, and we were told then that we are given the density. So there is the density of the gas, 1.964 grams per liter. And then finally, we're told that this is at STP, and what we're asked to find then is the molar mass. Okay, we're asked to find the molar mass of the substance. Okay. All right, so with that said, then let's go ahead and set up our problem. And so this is a conversion. This is just another simple conversion that you're able to do. So what are we starting out with then? This is what we're starting out with. We're starting out with the density. So I would suggest you write it this way here. So we start out with 1.964 grams, and I would suggest you write it in this manner here. So it's grams over liters. It just makes solving the problem a little bit easier. Okay, so there it is. We are starting out with the density. Okay, so that's what we're starting out with, and we are solving for the molar mass. So if you remember from the previous slide, we saw then that we're going to multiply the molar volume. So we can use the molar volume here because this is a gas at STP. So let's go ahead then. I'm sorry. Whoops, switched it here. Let me go back real quick, sorry. Okay, so the molar mass, remember, is in units of grams over moles. And so this is the reason why I wanted you to write the density in this manner. So write it in a vertical manner here. So you can see that the grams unit will be in the numerator, and we need to make sure that we convert the liter unit to moles. And so let's go ahead and plug in our molar volume. Molar volume, remember, is 22.4 liters of whatever this gas is. We don't even need to know what it is, over 1 mole of the gas. Why do we do it that way? Unit liter cancels out. And so grams is still in the numerator. Now we've introduced the unit mole into the denominator. The dimensional analysis is done. We can go ahead and multiply this through. We end up with our answer then as being 43.99 grams per mole. And that, folks, is our final answer. Okay. Okay. So with that said, then I would like you to go ahead and try this problem here. So you have an example there. Let's take a look at number 24 in your problem set. Let's work this through really quickly. Again, what I'd like you to do is, if you can't quite get the answers, at least try to set up as much of this as you can. and then we'll go over it when we come back, okay? So go ahead and get this problem done. Okay, let's go ahead and let's take a look at this then. Let's identify what we were given in the problem. Let's go ahead and mark it up here. So if you notice, we have a gas, okay, and we have this gas at STP, so the two conditions that we need in order to use the molar volume. But let's go ahead and look at what we have. So whatever this gas is, we were told that we were given the density. So we have the density here. So we were, this is what we're starting out with, okay? And they're asking us to solve for molar mass, and this is what we want to end up with. Okay, so this is what we want to end up with. Okay, let's go ahead and set up our conversion problem and get this done. So we start out with them with 0.902. Again, write it vertically, grams per liter. We want to solve for the molar mass in grams per mole. And remember, this is always going to be 1 mole here, and this is going to be 1 liter. This is a unit ratio. Okay. All right. So with that said, then, since this is a gas at STP, we can use the molar volume. Okay, so the molar volume is going to be 22.4 liters of whatever this gas is. Again, we don't need to know the identity of the gas to do this problem, over 1 mole. And why do we set it up so that the volume is on top and the moles is on the bottom? So the unit liter here will cancel out. Okay. So when we plug that in, plug these numbers into our calculator, we multiply those two numbers together, we get our answer then as 20.2 grams per mole. Okay. Now, if we knew a little bit more information, we can go ahead then and identify that particular gas, what it is. Okay. All right, let's do one more. Let's do one more. Take a look at number 25 in your problem set. Okay, and take a couple minutes to set up this problem and work it out, and then we'll work it out together in just a moment. Okay. All right. Let's go ahead and identify what we're given here, folks. Same thing. Okay, so we have we were given, so STP, we got that. Okay. I can tell you here, dihydrogen sulfide is going to be a gas. So we have gas at a STP. All right, so we were given here the moles of the gas. So that's what we were starting out with. That's what we're starting out with. And what do they want us to solve for here? They want us to find the volume. So folks, this is not a density to molar mass problem. Okay, so I threw it in here just to get you to see then you got to read these problems carefully and make sure you identify what you start out with and what you end up with. Okay, and that will help you determine then what conversion you will do. So this is a simple molar volume conversion. Okay, so let's go ahead then. What we're starting out then with is 2.45 times 10 to the minus 3 moles of dihydrogen sulfide. And what we're solving for here is the volume in liters of dihydrogen sulfide. This is not density, folks. Remember, you got to read the units carefully. The units here are not the units of density, it's just simply moles. So this is not a density to molar mass conversion. Okay, so again, I threw it in here to get you to answer the 3 basic questions. Once you answer the 3 basic questions, you can identify what type of conversion this is. Okay, all right, very good. So with that said then, we will plug in the molar volume with 22.4 liters of dihydrogen sulfide on the top and 1 mole of dihydrogen sulfide on the bottom. Why do we do that? That allows us to cancel that out. If you plug in the numbers correctly, then you'll end up with your answer then as 0.0549 liters of dihydrogen sulfide. Okay. All right, very good. Let's do another problem. It's try number 26 in your problem set. Take about a couple minutes again to work out this problem here, and then I'll work it out for you. Okay, so at least try to set it up. Okay, let's go ahead and let's take a look at this problem. Let's go ahead and identify what we're given, folks. Okay, so they want us to find the density. So we have density here, so we know that's what they are asking us to solve for. So that's what we want to end up with. So that's what we want to end up with. Okay, let's continue reading the problem. What is the density of oxygen gas at STP? All right, well, we have a gas, we have it at STP. So they want us to find density. So this is a conversion involving density and molar mass, but there are no numbers. There are no numbers that are given to us here. How are we supposed to obtain then the number that we need to start out with? Well, folks, they identify for us right here what the gas is. They tell us that it's oxygen gas. So this is what we start out with right here. But if this is a molar mass to density conversion, how do we know what the molar mass is of oxygen gas? Well, let's go ahead and work this out then, folks. But that's what we have here. Okay, so we need the formula for oxygen gas. And you need to remember then that oxygen gas is a diatomic gas. So as a diatomic gas, then the molar mass of this particular compound is going to be just take the mass of one oxygen atom, which is 16 grams per mole, okay? And then we double that. So therefore, the molar mass of oxygen is going to be 32 grams per mole. So actually, they do give us the molar mass. They just give it to us indirectly because they identify the substance for us. And that's why when we started out the lecture today, the period today, I asked you to do um, to write the formulas for those compounds that I gave you. Okay, so you got to be able to get these molar masses correct. Okay. All right, so with that said, then what we're doing is we're starting out then with molar mass. So we're starting out the molar mass of oxygen, which is 32 grams over mole. Okay, and we want to find the density of this gas here in grams per liter. So this conversion then will always take us from grams per mole to grams per liter. Okay, the unit of volume will be liters, unit of mass will be grams. Okay. All right, so with that said then, we're going to use the molar volume here. We know we can because this is a gas at STP. And so the molar volume, remember, is 22.4 liters for every 1 mole. Here, we're going to divide by the molar volume. Why? Because we need to put 22.4 liters on the bottom. But if we want to do that, the unit mole then cancels out. And if you do that, you'll see then grams will be in the numerator on both sides, and we've just introduced then the unit liters in the denominator on both sides. Okay. And so then, if you just go and carry this out, the calculation out, we end up with our density then as being 1.43 grams per liter. And there's our density. So make sure you read these problems carefully, folks. So the homework that I'm going to ask you to do tonight, make sure you read it carefully. And the problem that I'm going to ask you to do in just a moment. Make sure you read these problems carefully, identify what you start out with, identify what you're going to end up with, and then choose the correct conversion factor in order to get that done. Okay. So that's it for the mole here, what it is. And so what I'd like to do tomorrow then, and we're going to spend a good portion of the time tomorrow talking about how working through quite a few of these problems to help you. Okay. But we're going to talk about how we can do these conversions here. Okay. And so make sure you take a look at this, practice these problems here. And tomorrow then we're going to focus in on this. Okay. So make sure you get the work done. Okay, make sure the last problem that I'm going to ask you to do in just a moment, make sure you get that done as well. And then we'll go over these, how to do all 3 of these conversions. So there's these conversions, so how we'll do all those conversions. We'll review that tomorrow. And then I'm hoping then that we can start then the last section of this chapter, which deals with percent composition and how we get empirical and molecular formulas. Okay. So please preview that. Please review the 4 different conversions that we've done up till this point. Practice it, and then come on by after school today, 3:15 to 4:15 on our Zoom Meet site, and then ask your questions. Okay. So hopefully I'll see you folks after school today. If not, I'll see you folks tomorrow in lecture. Okay. Have a good day, folks.